Welcome to the Masons Podcast, your source of insight and innovation in New Zealand building and construction. Each episode explores the products, systems and solutions that support trades, specifiers and developers to deliver high-quality, durable and efficient buildings across Aotearoa, New Zealand. From building envelope performance to flooring, acoustics and fire separation systems, we share practical knowledge and ideas that help shape the built environment.
Good morning, everyone, and welcome back to the Masons Podcasts. Today, we're talking to Arthur Whitfield, and we're heading up into the roof space to talk about something you can't always see, but can definitely cause big problems if it's ignored, and that is condensation in roof spaces. We'll look at where that moisture comes from, the building science behind it, and what it can mean for the health of the building if it's not properly managed. So Arthur, could you expand a bit more on what causes this condensation? What can happen if it becomes excessive and why?
Yeah, sure. So the condensation that people will sometimes notice in a roof space is a function of the moisture content that's in the air in that space and a change in temperature. So what will happen is that as temperature drops in that roof space, usually this is overnight or very much in the colder months as well as overnight when the sun's not up, the temperature drops to the point at which the condensation will coalesce. That's called the dew point. And what happens is condensation will then appear on surfaces, typically the coldest surfaces, so that will tend to be the roof decking and the roof underlay, which is close up against the roof decking. Okay. People will see a lot of condensation there. Well, they can see a lot of condensation there depending on the situation. Condensation in cold roofs is reasonably normal. It's catered for. It's sort of part of the design, especially the roof underlay characteristics. But what can happen is if there's too much condensation, because there's too much moisture in the air, is that condensation can start to become heavy and fall down onto insulation, framing, and metal components. And that cycle of condensation and wetting and not completely drying is just repeated over and over. That can become a problem over the life of the building.
Okay. And you mentioned in there cold roofs.
Right.
What is a cold roof?
A cold roof design is the most common type of roof design in New Zealand, and that is where the roof decking level is not insulated. The insulation is at the ceiling level. Okay. And that's very, very common. People are very familiar with lofted insulation or bulk insulation above their ceiling linings, and that's to keep the occupied spaces at the temperature that people want them to be kept at. Essentially, we usually talk about warmth, maintaining warmth. So the opposite is a warm roof design. Something a little bit newer for New Zealand, quite popular overseas, especially in countries with weather extremes. And the difference is the insulation layer is at the roof cladding or roof decking line. There may also be ceiling insulation, depending on the situation, but That's the main difference, cold roof to warm roof.
Right, so that's becoming a bit more popular, but generally our cold roofs are what most people have in New Zealand here.
That's right.
Yeah. So the main causes of the condensation within the roof space, the biggest one is the warm, moist air rising from our living spaces, isn't it?
Right. So the air in the roof space will hold moisture as a matter of course. Like all air, unless you're in a desert climate or a controlled climate, will have a certain amount of moisture content. What can happen, it doesn't happen in every home or in every situation, moisture-laden air can rise from the living spaces. We keep the living spaces typically warmer, more comfortable. Mm-hmm. Warmer air holds more moisture. And what will happen is if that air from the living spaces finds its way into the roof space, perhaps leaking past downlights or penetrations, the attic hatch is often a main suspect. Water vapor itself can slowly percolate through the ceiling lining and that sort of thing. Right. If it finds its way into the roof space and doesn't find its way out, that's when we get into the realm of too much moisture content in the roof space, and it can also result in excessive condensation, problem-causing condensation. So it's not every building, it's not every home. It does tend to happen more with modern buildings with reasonably airtight, long-run roofs, metal roofs with modern flashings. Okay. And well-insulated living spaces.
This warm, moist air is produced just from us cooking, from showering, clothes drying, even just simply breathing. Yep. And forced up through all these small cracks in our ceiling, which we think it's sealed because it looks it, but there's a lot of air gaps in there. Let's just talk about ventilation. In the old days, they'd have a lot of airflow going through the roof, but now they're a lot more airtight than what they used to be.
Yeah.
And that ventilation isn't taking that warm, moist air out. So
That's right. So going way back, roofs were either naturally kind of a little bit air leaky, just through the different roofing methods, and also there was sometimes insulation deliberately built into that roof space, especially if there was gable ends and that sort of thing. Then you have the different types of roofing. Your tile roofs tend to be naturally a little bit more air leaky. So there's a little bit more natural air change occurring. And you also have your shingle type roofs where there was ventilation built in as per the design. We don't tend to hear about those during condensation complaint season.
Okay. So if I got up in the roof space and I saw water dripping from the underlay, is that coming through the underlay?
No.
Okay.
And this is the common misperception, and people become very concerned when they get up and they see an enormous amount of condensation formed on the underside of the underlay. The immediate thought is there's some problem with the underlay. And it's, I can understand the logic of that, but it's not the case. As we've mentioned, it's simply the temperature is dropped to the dew point, the moisture content in the air coalesces out or condenses out onto the surface, usually the coldest surface, and that tends to be the underlay, which is right up underneath the metal cladding.
Okay.
The thin metal cladding, which obviously passes the temperature change through very readily.
Yeah.
Now, you asked about dripping. So can I just say that a certain amount of condensation forming on the underside of the underlay in a cold roof is not abnormal. In fact, that is normal, and underlays are required by New Zealand standards to absorb a certain amount of condensation, to act as a reservoir, temporary reservoir, and then to slowly release that again as the roof space warms. The sun comes up, the roof space starts to warm, the condensation is absorbed back into the air, everything's fine. You mentioned dripping. If there's condensation dripping and a lot of condensation dripping, that indicates excessive condensation. And that's
a problem.
Yes, that certainly over the life of the building, that can be a major problem.
Okay. And what can happen when we get this excessive moisture up there and we do see dripping?
Yeah.
What's going to happen in the roof space?
You've got damp timbers, you've got damp insulation, and that's a major problem because wet insulation doesn't perform properly. You're not getting your correct insulation, and you potentially have an environment where you could have mold growth and that sort of thing. Also, if there's liquid or water around metals, there's potential there for corrosion cells to set up. So if it's excessive, and by all means, don't want to panic people, it's not always the case. If you have a lot of excessive condensation on a regular basis, you're going to have durability problems overall. That's the short version of that.
Yeah, for sure. Thanks for that.
Yep.
So what's the correlation to homes being better insulated and being naturally more airtight these days?
Sure. So it may not seem obvious, but because we're doing a much better job, especially with new builds or renovations, of increasing the insulation, reducing the heat loss through windows by double glazing or even triple glazing, and our building methods just mean there's a more natural air tightness. There's a lot less natural air change. And what that means is the temperature inside the living spaces tends to be held more evenly, often at a higher level. So we're talking about it being warmer, more comfortable. Warm air holds more moisture, as we heard earlier. That's just science. And if this warm air that holds a bit more moisture finds its way into the roof space, that's when the trouble starts.
Right.
And so that's the correlation. Slightly more airtight homes, warmer, better insulated. Warmer spaces means more moisture in the air, and if that air gets where it shouldn't do, that's when the trouble starts.
Yeah, we were trying to make them more energy efficient, but this actually increases the condensation risk rather than decreases it.
Now, you've touched on something there. So brands advise, and have done quite a bit of work on this, they advise that there's a strong need to ventilate the living spaces. So that's the place to start with any condensation control, is to get adequate ventilation into the living spaces. So this is something building designers and builders need to consider strongly and closely, and it may be more than just good extraction in the wet areas or the cooking areas.
How does this moisture-laden air get into the roof or attic space?
The warmer air wants to rise, so it will find its way through any gap or any crack. It'll find its way through downlights. It'll find its way through the attic hatch. It will find its way through any gaps or penetrations where services have been run, or just about anywhere it can. Any apertures the air will go through and take its moisture load with it.
How would someone initially notice this condensation, and why is it said to be such a problem?
Okay, so I'm just going to answer that sort of in a few parts. First of all, if you have a tile roof of any kind, if you have a shingle roof, you probably don't have an issue. If you have an older home that has not had a new long-run aluminium or steel roof put on with modern flashings, you may well not have an issue. Or an older home that has just naturally got a bit more air change going on, possibly not so well insulated. You're unlikely to be having any issue. So I don't want to worry people. People typically notice it when they have had a new roof put on. They've invested a lot of money. They get up there to sort of like see what's going on, and they notice condensation. Sometimes they might notice a lot of condensation and they get very concerned. The other thing is during new builds or construction, and we can talk about that later in the pod, people will sometimes notice a lot of condensation in the underside of the underlay during construction, and there are good reasons for that. And in the very worst of cases, and this is not common, but it does happen, people might see water staining on the ceiling.
Yes.
And that is indicative of major issues with moisture in the roof space.
By the time you see it down below,
you're in big trouble.
Yeah. So visually, you'll see possibly stains on the ceiling. You might smell a damp smell.
That's extreme. It's not common. Look, most people won't need to concern themselves with this because that natural cycle of condensing, absorption, and then re-release into the air it's part of cold roof design in this country. And when things are in balance in terms of a little bit of natural air change in that ceiling space, there won't be an issue. The things to look out for are newly re-roofed homes or brand new homes that are built with
more
moderately airtight, long-run construction. That's when it can be an issue.
And can you tell me why it's such an enhanced problem with long-run steel roof cladding as opposed to other roofing types?
With a building that's constructed with long-run and in the modern flashings and modern fixings that we have, there is not much opportunity for natural air change. You've only got a few little gaps in that roof, and that it may not be enough to cope with the moisture loading in that atmosphere or the air in that roof space. That's the issue. So designers who are aware of this problem and aware of the issues that have been overseas and the standards overseas that call for roof space ventilation, they actively design for the situation. And there's a number of things that can be done with new builds, and there are some things that can be done with existing homes as well if people are concerned about excessive condensation.
What can people do in an existing house if they want to combat or reduce condensation in their roof space?
So first of all, I just want to emphasise that a certain amount of condensation in your cold roof space is not necessarily a problem. If it forms and then dries off again, basically goes away later in the day, you don't have an issue, you don't need to be concerned. However, if you have got excessive condensation, where the condensate is falling down on your insulation or your ceiling or your timber, what can you do? It's a bit harder in an existing home, but people can do things like get a degree of air seal into their ceiling space, seal up any gaps, seal up any penetrations, a soft seal around your attic hatch, get your downlights changed or your lighting changed to an airtight version. You could ask a roofer to come and put a ridge vent in at the top of your roof. And the most important thing, the first thing to do, is to make sure that your living spaces are properly ventilated. The first step that Brands advises is take care of the living spaces first. Second step is to make sure your ceiling is completely airtight as you reasonably can. Third thing is to get ventilation into your roof space. Now, it's probably unreasonable to lift a roof and put a whole lot of ventilated battens and things in there, but putting on a ventilated ridge, it is cost effective and it will do some good.
But if you're replacing your roof, that's a great idea to put that ventilated battens in.
Yeah, so if you're budgeted and planned or booked a re-roof, talk to your roofer about getting a passive roof ventilation system installed.
Okay, and if you are doing, say, quite a large refurbishment of your house and you're removing your ceiling linings, a great idea is to put a vapour barrier in there.
Absolutely, and you'll probably upgrade your ceiling insulation as well.
Yes,
at that same time.
Increase that.
They could also look at a solution for their ceiling, such as PIR board, aluminium-faced PIR board, so you get the benefit of a complete vapour barrier as well as really, really good insulation. So there's all sorts of choices out there if you start pulling things off the walls or roof and refurbishing.
Yes, then you can do a lot more. Okay, so what about new houses? This would be an easier scenario as you can design from scratch and can allow for various controls.
Yeah, well, you put your finger on it. You've mentioned design. So we do get people ringing us up. The building is built. It's not finished, but basically they're at painting stage internally. And the boys have got up onto the roof and there's massive condensation and they think the underlay's failed. What's happening there is that the moisture load from the concrete slab, curing concrete slab, the plaster, the paint, the timber, everything finds its way up into that attic space or roof space, and it's the same scenario as before. It's condensing out at dew point and it's presenting as condensation. It may or may not be excessive and falling. That will probably regulate itself over time. But going back to your question, what I'm really saying there is once the building is built, if design elements haven't been brought in to ensure against excessive condensation over the life of the building, it's no different to an existing home. So going right back to what you said, it's essential the designer and the builders plan for this. The first thing to do, make sure that those living spaces are really well ventilated. And it's becoming more popular even in homes, not passive homes or high energy efficiency homes, to get for your mechanical heat recovery ventilation systems.
Yes.
Because you get fresh air brought in, you get the heat exchange from the heat that's already in the home, and you get the exhausted air, including moisture content, taken out. They are brilliant.
Yeah.
The next thing is to make sure that ceiling is airtight. In a new house, you've mentioned a couple of options already. That is a fairly inexpensive thing to do
It is.
at construction stage, and that's going to make a huge difference. And the third thing is get a passive roof ventilation system built into the house during construction. We are talking long-run roofs here.
Yes.
Not worrying about tile roofs,
No.
not worrying about shingles or whatever.
Can we comment on interstitial moisture?
Sure. So that is where moisture will form inside an assembly. So what we're talking about there is a wall assembly or a roof assembly. So I guess the closest thing in terms of roof spaces would be skillion roofs, where there's very little air volume in there. You have the roof cladding and the underlay in close proximity to the insulation. And whether it's interstitial or whether it's condensation, such as we've been talking about with cold roof spaces, they're very similar things.
So how does that compare with surface condensation that we're talking about here?
They are very much related. With the condensation we've been talking about a lot this morning with regard to cold roof spaces, we see the condensation forming typically on the underside of the underlay. We may also see it on ducting work. We may see it on timber members. We see it. The difference with a skillion roof is that we're not seeing that condensation. We don't see it. It's there.
It's hidden.
It's there unless the designer has taken substantial steps to ensure that there's really good cross-flow ventilation. That's the difference. It's hidden.
Okay. Arthur, what else do people need to know about condensation in cold roof spaces in Aotearoa, New Zealand?
I think we've covered a fair bit of it. I do want to emphasise that this is a problem that crops up sometimes. It tends to crop up more with modern homes or with homes that have been extensively renovated. It's a problem where people use modern long-run materials, including modern fixings and modern flashings, which have substantially reduced the natural air change in the roof space.
Yeah.
So those are the things to look out for. The good news is there's lots that can be done. And in most cases, simply ventilating, it sounds simple, but ventilating your living spaces more than you are now is going to help a great deal. Other things, making sure that that ceiling level, we're stopping air moving into the roof space. That's a huge help, according to Breen's research.
Yep.
And the last thing to consider, or maybe one of the first things to do if you're building a new home or doing serious renovations, including taking the roof off, is get a passive roof ventilation system going in your roof space.
Yes.
You'll never have to think about it again. It will do its job for the life of the roof, and you will not have to worry about excessive condensation.
That's great. Great message. Now, if there was one or two things a building designer or a builder could do to reduce the likelihood of heavy condensation in the roof space or the cold roof design, what would it be?
Yeah, so look, I'm going to touch on some things I've touched on before. You've mentioned two, I'm going to mention three.
Okay.
Ventilate those living spaces, seal that ceiling line, and introduce ventilation into your roof space. That's the three in that order, and the problem is tackled.
So those three steps alone address over 90% of your condensation issues.
Probably 100% if they're done
Right.
properly. Excessive condensation.
Yes.
Cold roofs will always condensate.
Are there any final things that we need to know about condensation in cold roof or attic spaces?
I don't think there's anything new to add. There's a need for balance in this. It's not a major problem that's occurring all around the country, but certainly in new builds, it's something to be aware of. Long-run cladding, roof cladding, new builds.
Specifically.
And re-roofs, in situations where there's a high moisture load in the living spaces, that's something to be aware of and to think about, and things can be done. That's the good news. These are solvable concerns.
Solvable problems.
They are. Yeah.
Thank you so much, Arthur. That concludes our discussion on moisture in cold roof spaces. Understanding how condensation forms and the steps you can take from proper ventilation to insulation and air sealing, it really is key to protecting your roof structure and home. Thank you for listening, and stay tuned for more insights on building smarter, healthier homes. Until next time.
Thanks for listening to the Masons podcast. We hope you've gained some practical insights and ideas for your next project. Be sure to subscribe so you never miss an episode, and visit us at mpb.co.nz for more information on our product, systems and solutions. And join us next time as we continue to explore smarter ways and solutions for building in New Zealand.
This podcast is for general information only. While we aim to provide accurate details on building products and systems, Masons is not liable for reliance on this content. Always follow product specifications, manufacturer's instructions, and relevant building codes.